Okay, today we're going to talk about law of cosines. And law of cosines is actually a set of three formulas. And if you work with it and notice the patterns, they're really kind of easy to memorize even though they're pretty complex. But I won't require you to memorize them. But you might find it handy, especially if you're going into trigonometry, to try to memorize them. Okay, so putting this in context of our generic triangle here, we have a squared, side length a squared, is going to equal b squared, so side length a squared, is going to equal b squared plus c squared minus 2 times bc times the cosine of a. Okay? So, if we see what we're dealing with here, what we're really dealing with, and it's ideally suited for, is if you're trying to solve for a side, but you're given two other sides with an included angle. Okay, so a side angle side position is really ideally suited for law of cosines. Now we have two other restatements of that law that allow us to easily solve for any other sets of angles or sides. Okay, but let's first talk about the side angle side method. Okay, so in this case, again, we're solving for two sides with the angle between them, and the steps to solving are pretty easy. We're going to use the law of cosines to find the angle or the side opposite that given angle. Okay, and then we'll use the law of sines to find the angle opposite the shorter of the two given sides. And what we want to do with this, why the shorter one, is because we're trying to eliminate the possibility that we could have two situations here, or two solutions for the law of sines. So if we make sure that that angle is always going to be an acute angle, we don't have to consider a second possibility for that. And then, of course, we'll find that third angle by subtracting the sum of the first two from 180. So let's see what this looks like with this triangle here. And I've drawn this triangle out so you can see that what we really do have here is a side, an angle, and a side. And these are proportional. I drew them out on Geometer's sketch pad so that you could see what it really looks like with this triangle. Okay, so the first thing we're going to do is to try to solve for side length C here using the law of cosines. And if you have a calculator that you can use for this, it's going to be a lot easier to plug all this in with a calculator. And you'd still want to write your work down and document what you've done so you can error check it later, but it really is not that bad. So c squared, so this should cue in your mind at the very end, you're going to take a square root, is going to equal a squared, which is 29, plus b squared, and that length was 13, minus 2 times a times b times the cosine of c, which is 41. Okay? So, taking this step by step, 29 squared is 841, 13 squared is 169, 2 times 29 times 13 was 754, and then we have the cosine of 41. Adding our two numbers together, we get 1010 minus 754 times the cosine of 41. And at this point, this is where you want to put it into your calculator. Actually, if you have a TI calculator, you could have put it at the very beginning and skipped these other steps. But we end up with, and you could have actually done it, just put the whole thing under a square root when you have this configuration. But I'm using a regular calculator, so we have c squared will equal 440.95. And then c will equal the square root of that, which is 21. Now, we want to find, remember, we want to find the angle opposite of the shorter sides. Well, the shorter side was side B, so we want to find angle B with law of sines. So next was find angle B with law of sines. Okay, so we're going to use the given information for that, and that's going to be side C, which was 21, over sine of 41, will equal side B, which is 13, over sine of B. And solving for this, we'll get 21 times the sine of B will equal 13 times the sine of 41. I'm going to erase this because my 13 looks like a B. Okay, so sine of B equals 13 times the sine of 41 divided by 21. And taking our inverse sine, and because we know this is going to be an acute angle, we don't have to consider the other option. B is going to equal 23.96 degrees. Okay, so we needed to find side C, angle B, and then the last thing we need to find is our other angle. We need to find angle A, and that's just going to be 180 minus 41 minus 23.96 is going to equal angle A. So angle A is going to equal 115.03 degrees. And there we found the missing pieces that define our triangle. Okay. There's one final configuration that we need to consider, and that configuration is a side-side-side triangle. And for this triangle, all we are given is 3 sides. Okay? And we want to first use the law of cosines to find the angle opposite the longest side. So let me draw this out. So here we have 8, 7, and 4. So this will be angle C, angle B, and angle A. Now, the angle opposite the longest side is going to be angle A. So for step 1, we want to solve for that side that's opposite the longest side, which is angle A. Or solve for that angle. Okay? We're going to do that with law of cosines. Now, when we do that, we're going to have to end up taking an inverse cosine. We're going to use the C version of this. So C squared is going to A squared. A squared version. So A squared equals B squared plus C squared minus 2AB cosine A. 2BC cosine A. That looks like an E. Okay, so when we plug this in, we're going to get 8 squared equals 7 squared plus 4 squared minus 2 times 7 times 4 times the cosine of A. And we get 64 equals 49 plus 16 minus 56 cosine of A. Subtracting over what we can, we get negative 1 equals negative 56 times the cosine of A. So the cosine of A equals 1/56. And taking the inverse cosine, we get that A is equal to 88.98 degrees. Remember, we're looking for 3 angles here because we were given 3 sides. Next step is we're going to use the law of sines to find either of the remaining 2 acute angles. What we've done here is we solved for law of cosines using law of cosines for the angle that was most likely to be acute or obtuse, greater than 90. Okay, the other 2 will always be acute. Therefore, we won't have to consider that we might have 2 solutions with law of sines. Okay. Okay, so I'm going to solve for angle B next. I've already solved for angle A, and then C I'll get with substitution. So I'll have 8 over the sine of 88.98, which I just, because 8 is side A and 88.89 is angle A, equals 7, which is side length B, over the sine of angle B. And when I solve for that, I get 8 times the sine of angle B equals 7 times the sine of 88.98 degrees. And therefore the sine of angle B is equal to 7 times the sine of 88.98 divided by 8. And taking the inverse sine of all that, we get B is equal to 61.03 degrees. And then the third angle we will find by taking 180 minus 88.98 minus 61.03. And so angle C is going to equal 30.08 degrees. So those are our 3 angles that we need to find when we're given the side-side-side configuration. Okay, so we have given you all the different steps to finding 5 different cases of triangle configurations. And hopefully this will help you. Hopefully this will help you make sense of everything. I'm going to move this up a little bit and kind of do a little synopsis of which configurations belong with which law. And if you want to put this on the back of the sheet, you can. Okay, so remember, law of sines, we're going to use with either angle, angle, side, angle, side, angle, or side, side, angle configurations. And law of cosines, we're going to use this with side, angle, side, or side, side, side configurations. Now, remember, the one you've got to watch out for is this side, side, angle business, okay? Because you have the possibility for those different configurations of the triangles. Okay, so that could be a tricky one. Just know what you're dealing with. Look at it in terms of these triangle angle side configurations, okay? And make sure you know what you're supposed to be doing for each one. Okay? I hope that helps. We'll get lots more practice in class.